In today's session, we're gonna talk about loops and iterations. We have two loop statements that we use a lot in programming, and they are the for loop and the while loop. We have used the for loop before, and we're gonna review the for loop that we have used. Also, we're gonna take a look at how to use the while loop. This is the while loop. Before we go to while loop, let's review what we have learned when we use for loop. We'll go back to Replit, and let's say we have a variable x equals 5, and then for I in range. We've used the range function, and in the range function there are three components, and two of them are optional, and the first value is optional. If we do not mention the first value, we only use one value in the range. That means it starts from 0 and it goes up to 4. If we say range 5, that takes 5 values from 0 to 4. 0 to 4 makes 5 values. And when we start a for loop, the statements that we want to execute repeatedly, a loop executes some statements repeatedly, and the statements need to be indented. Those statements that we want to execute repeatedly need to be indented. So let's say I want to print I, and we need a colon here, and when we finish the indentation, that's the end of the for loop. And let's say another print. So in this example, we have a for loop and one statement under for loop. This one statement will execute repeatedly, and that's why we call it as a loop. Normally, the statements in a program execute from top to bottom. So line 1 first, then line 2, then 3, and then 4. That's what the normal flow is. But when we have a loop, it goes back to previous line. For example, as you can see, the print statement at line 3 is under the for loop because it's indented. And then when the indentation goes back or unindented, that is the line 4, this is not part of the for loop. So when executing line 1, 2, and 3, and then it goes back to line 2, it goes back to the for loop, okay, instead of going to 4. And then again 2, 3, and go back to 2, 3, 2, 3, 2, 3, and it will execute for a certain number of times. So it is looping back or going back. That's why we call this for statement as a loop. And if you remember the range, this for statement, the variable I will take different values starting from 0. If we don't mention anything, only one number, then it starts from 0 and goes up to that number, but not inclusive. This number is not inclusive. It goes from 0 to 4. We can mention the first number. For example, you can say 0, 5. That will that's the same as only if we mention in bracket 5. So it will start from 0 and will go up to 4. But if we want to really mention the first number, 0 doesn't need to mention, it's automatically 0. We can say 3 to 5. If we do want to get the variable I different values from 3 to 5, then we need to mention the first number as well. Also, we can, let's say 3 to 15. So I value will start from 3, will go up to 14. And will increase each time it comes back to this for statement while looping, it will increase the value by 1. So the value of I first time will be 3, next time when it comes back will be 4, next time when it comes back will be 5, and then 6, 7 until 14. So it's increment by 1 automatically. We can also increase by 2 or 3 or any other value. So if we mention 3 numbers, okay, then the first number is the start of the value for I variable, and last number is the increment. So first time I will have 3, next time I will have 3 plus 2, that means 5. Next time it will have 2 more, 7, 2 more, 9, and it will not go beyond 14. Okay, so 14 is the last possible value, but if by increment, if it lands on 14, that's fine. It may not land on 14. It will not go to 15 or above. It will finish before 15. So if you run this one, as you can see, it by increment by 2 started from 3, increased by 2, okay, 3 and then 5, 7, and it landed on 13. But next number is, if you increase, next number is 15, but that is not part of the values possible according to our definition of range. So it stops at 13, and then when it finishes, it comes to this statement and say end of for loop. Okay, so when we simply mention one number that starts from 0, goes up to 14, increase by 1. Okay, if you mention 2 numbers, the first number indicates the start, second number indicates the end, and we don't have the third number, so it auto increase by 1. So it will start from 4, go up to 14, increase by 1. If we mention 3 numbers, first number is the start, second number is the end but not inclusive, and third number is the increment. And here the range function shows actually the format, and each number is separated with comma. So start is an integer number, stop also an integer number, and step is like the increment. Okay, so if we increase by let's say 5, so it will start from 4, next one will be 9, next one will be 5 more, so it stopped at 14, right? If we go 17, still it will stop at 14. It will not go past 17 or above. Okay, so this is how a for loop works. We have a loop control variable, which is I. Typically we can have a value before, but because the for loop has an initial value right here, it starts with that value. Doesn't matter what value you have initially. So this value doesn't have any impact on the for loop. This is where we start for the I variable. Okay, so this is like meaningless for this program, so I'm turning it off. Even if we don't mention the first number, actually when we mention 2 numbers, the first number is the start and second number is the stop, and it will increase by 1. In the current code, what do you think will be the output? What do you think will be the output? First is the start, okay, and then second is the end, and third number is the increment if we have any. If we don't have any, then it increases by 1. What do you think will be the output of this program? So it starts somewhere and then checks if the current value is more than or equal to the second number. Okay, if it is, then it stops. If it is not, then go to the loop, execute the statement, and then increase the number. That is called the step. By default, if we don't mention anything, then the step is 1. So what do you think will be the output of this code if I run? Anyone? Anyone? No output, because let's run this. and you see no output for the loop. And the explanation is this. So initially it takes the value 17, and then it checks the condition. Here is an invisible condition, and the condition is if I is less than 5, then execute. If it's not less than 5, that means equal to or above, then don't execute. This is the condition. So the current value is 17, and it is not less than 5, right? So it doesn't execute anything. Okay, what we wanted to show that if we have two values, then the first one is the initial value, second one is the stop value, start value, stop value, and the third one is increment if we have one. If we don't have two values, then the first one is 0, and the one that we mentioned here is the end. Okay, it will end at 4, and the increment is also 1 by 1. If we have three numbers, then we can control more precisely where to start, where to stop, and how much is the increment. If we don't mention two numbers, only one number, then start from 0, increment by 1, and stop before the number that we mentioned. Okay. Also, we can use the step as negative. Okay, step as negative. So remember, when you have a step, you need to have three numbers. Okay, so if I mention -1 and I want to say this is the step, then I need to have two other numbers. So I need to have stop, start, stop, and increment. Now, since it's negative, the first number should be larger, right? Let's say 10. So it starts from 10, and every time it comes back to the for loop, it decreased by -1, decreased by 1. Okay, the step is -1, that means it decreased by 1. So it will start at 10, and it will keep decreasing. Now the condition is if it is greater than 5, then go to the loop. If it is not greater than 5, then it will go out of the loop. Okay, so on this, and you see started from 10 and up to 6, it was greater than 5, and it ended when it became equal to 6. It doesn't really become equal to 6, it stops one step before. So if I get out of the loop, for example here, and then print I again, still I is a variable, right? You will see the result of I, what I has. Last value of I is 6. It didn't really get 5, but the condition is like, it's an invisible condition, is like it goes up one value before that last number or the end value. Anyway, so normally what we use like this. It starts from 0, increased by 1, and stops at 9. Okay, so we'll see the last value of I will be 9. Okay, this is the last value of I. All right. Now we can use this for loop also for a string. Okay, for example, if we have a list of items, all right, then we can say the list in a square bracket. All right, and when we use a square bracket, we can mention a list of string. Let's say apple, and then comma. This list is a list of fruits separated with comma. So orange, comma, another value, okay, and then berry, okay, comma, let's say blueberry. And then mango. So this is a list, and the variable I will get these values. Okay, so it will start from the first value and end with the last value, but I can have these string values as well. Okay, so if I run, showing all those values, we're printing I, right? And let's put some name. Say Sally, say Bob, and in the print we'll say Happy New Year. Okay, and then the name. So what it will do, it will print this Happy New Year for every string or every name, right? Happy New Year, Joseph, Glenn, Sally, Bob. Okay, so we can use a list in square bracket, but the items should be separated with comma. Okay, also we can put values here, like number values. 5 number, we don't put in quotation mark, right? So 9, say 34, 23. So, and then we're not going to say Happy New Year, we're going to say those numbers. Okay, this will take the value starting from the first item, and we'll take including the last item. It's not like range. Range function is different. Range function start from 1 as auto increment, or we can mention the increment. And there's a list of item, and it will take every item that I mentioned in the list, right? So we can run, and it's showing I is taking those values. Sometimes this list is made from user input. In this example, the programmer is writing the list, okay? But we can also make the list as user input. So user can choose which number you want to use, and then can do some operations like find the largest number from the list. Okay, so user can randomly give some number, and the program will find the largest number, or the smallest number, or you can find, let's say, GCD among a couple of numbers. Okay, you can do many operations. When we learn more about list, we will go into more detail about list. That's in another class. But our focus here is to use for loop. Okay, this is how we can use for loop in different ways. All right, let's take a look at the slides. So next comes the while loop. Okay, now while loop is a little bit different than the for loop, and let's build the while loop in here. You see how the for loop works, right? And let's use the range as a comparison so that we can easily compare. And the for loop, now start off while loop. Okay, and then we're going to use while. So the while loop structure starts with the keyword while, and then after the keyword while we need a comparison. We need a comparison, and typically a comparison it comes with the variable and the value. So let's say while I is less than 5, okay, then colon, and then all the statements that we want to execute under the loop. So let's say print I, okay, and when we finish the loop, we unindent, and then we continue with other statements. For example, the end of while loop. Okay, now if we don't have the for loop, okay, what will happen? I'm going to put the for loop back, and let's say I'm going to disable the code. So this is the start of the for loop. Now look, I is less than 5. It's going to check whether I is less than 5. But what is the current value of I? We don't have any current value of I, since we did not mention the current value of I. But if you remember, in the for loop, it does take the first value from the loop structure itself. So the first value is 0 automatically. It's coming from the loop structure here. Or if you use a square bracket, it takes the first value from the list, right? If you use a square bracket and put the list of items separated with comma, it takes the first value from the list. So I has a value. It doesn't need an initial value before. But when we have, since I has a value here, this error mark did go away as soon as I removed the comment sign, or as soon as I remove the I variable from the code. Now you see I is showing an error because I doesn't have a value. So when you use a while loop, typically what you will do, you will make sure that there is an initial value from where you want to start I. So let's say I equals 0. Okay. Now it will execute. What will happen, this will take the I value and then it will check if I is less than 5. If it is, it will execute the loop, and then before getting out of the loop, which is line number 8, it will go back. It will go back to while and will keep checking this condition. Okay, and when this condition becomes false, then it will jump out of the while loop and go to line number 8. So let's think about how this statement will be executed. It will print this line first, start of while loop. It will take the value of I as 0, and then it will check this condition, is I less than 5? Yes, so it will print 0, right? And then it will go back to the while and we'll check again, is I less than 5? I is 0, right? Still I is less than 5. So it will print I again, it will print 0 again. It will go back, we'll check, is I less than 5? Yes, I is still 0, and it will print I again, and it will go back, still 0. So the condition is true, will print I, go back, condition is true, will print I, go back, condition is true, will print I. When will this loop stop? What do you think? When will this loop stop? Any thought? Let's run and see when it stops, okay? Still running. I don't see the end of while loop. That means it's still running. And it's running so fast we don't see the difference on the screen. So let's stop and let's print something else, okay? So let's say if we decrease the value of I, now as you saw that the value of I did not change inside the loop. And when the value of I did not change inside the loop, this condition is never gonna be false. So if you really want to control a while loop, you need to change the value of I in the loop. For example, we can say I equals I plus 1. That means I'm increasing the value of I by 1. It will take the current value, which is initially 0, and then plus 1. So 0 plus 1 becomes 1. So I will be 1. It will go back and then we'll check, is I, which is currently 1, less than 5? Yes, it will print that I. So that means it will print 1. And then it will increase the value of I by 1 again. Current value of I is 1, plus 1 makes 2, so I becomes 2. And then it goes back. Is I still less than 5? Yes. So it will print 2. And then it will take the current value 2 plus 1, 3. I becomes 3. It will go back and then print 3. I will increase to 4. Will go back. Still condition is true. Print 4. Will increase to 5. Go back. The condition is not true anymore. When I becomes 5, that I is not less than 5 anymore. Okay, so let's run and see. It did start from 0 and went up to 4. And actually here I became 5. When I became 5, it compared with this, and this condition is not true anymore. So it's not printing 5 anymore. But still I is 5. You want to see what the value of I? When the loop ends, look the value of I. It will show that I actually became 5. And that's when this condition became false. It did not go into the loop anymore. It came out from line number 6. It jumped out of the loop, went to line number 9. All right. Now, the difference between a for loop and a while loop, you see, for loop, you can have a value in the loop itself, okay, and you don't need to increase. It has an auto increment, even if you don't, or you need to change the value, I would rather say. Instead of increase, I would say change the value. The value of I automatically changes. In while loop, the value of I doesn't change automatically. You have to explicitly change so that this condition becomes false at some time. Otherwise, it will become an infinite loop. Okay. Also, there are other ways to make it an infinite loop. So you need an initial value before the while loop. You will compare with typically with another value, but it can be with another variable as well. This side can have another variable as well. And then you do something with that I. A simple one is to show the value of I, but when we solve real life problem, you will do some other thing. And then this is also necessary, otherwise this condition will never become false. So that means this will become an infinite loop. Okay, so you have to be careful about the differences when you use a while loop. While loop needs an initial value. You need to change the value inside the while loop, otherwise it becomes an infinite loop. All right, let's focus on while loop only, and let's see. How about this? While I is let's say I is 5, okay, and while I is greater than 0, print I. Now, analyze this code and tell me how many times this loop will execute. By the way, you saw the term iteration. This iteration means going through the loop from top to bottom once. So that's one iteration. Executing the while loop once from top to bottom. That it means you did iterate through the while loop. So how many times the program will iterate through the while loop, or how many times this while loop will execute, or after how many times the while loop will end? Anyone? 5 times. Okay, so one response was 5 times. Let's try to figure out by going through step by step. Okay, so the value of I is 5, so this is true, print 5, I becomes 6. It goes back, I is 6, this is true, print that I becomes 7. This is true, print that I becomes 8. This is true, print that I becomes 9. Right? This is true, I is never going to be less than or equal to 0. It's increasing. From where we started, it's increasing, and the condition says greater than 0. What condition we use, what type of changes we make, depending on that, the loop can become an infinite loop. Let's run and see. So it's running so fast, you see that the number is increasing by thousands in every second. And it will keep going. Okay, so this became an infinite loop because this condition never becomes false. All right. So depending on how many times we want to execute, we have to use that variable, use the condition, and use the increment. Also, there is another format. Let's say this condition, when this condition is checked, it gives you a true or false value. Okay, let's start while I is less than 10. So it will start from 5, will increase and go up to 10. That's simple to quickly you can figure out. Start from 5, increase, so 5, 6, 7, and goes up to 10. Okay, so this is not an infinite loop. Okay, but when this condition is checked, it gives you a true false value. Remember, we saw some reserved words, and in those reserved words there was two words. One was true and the other one was false, and that starts with capital T, true, and capital F, false. So that gives you a true value or a false value depending on the value of I. If this is true, it goes into the loop. If it is false, it doesn't go into the loop. So this comparison has a result, and we can put that result here instead of comparison. Okay, and if we hard code this, that doesn't depend on the variable I, if we simply put a fixed value. So the comparison gives you either true or false, and that comparison had a variable I. Now I remove the variable I. Now this while loop doesn't depend on the variable anymore, because the condition is not using the variable. And when I say true or false, so while true it goes into the loop, while false it goes out of the loop. That was the representation of the condition. But now I am making permanently true in the code. So this becomes another infinite loop. Okay, let's run. Keeps going. And if I say false, that means I already gave the value false here. I did not evaluate the variable. I did not. This loop is not dependent on the variable. Okay, loop control is not dependent on the variable. I already gave a false value. So, how many times do you think this loop will execute? Anyone? How many times do you think this while loop will execute? It's already hard-coded false. That means it's false, already false. Okay, it's not evaluating any expression. It's not comparing, so it's already false. So it's never gonna go into the loop. All right. So it's gonna come to here, and it's only execute the lines after the loop. Anyway, so this true and false, which are those two are two reserved words, but they have numerical equivalent. And here false is the same as 0. Okay, so false numerical equivalent is 0 and true is anything other than 0. So false means 0 and normally true means 1. Okay, many people indicate true as 1, but true is actually anything other than 0. That is true. So by keeping this information in mind, we can put here 0, while 0 means while false. Also hard-coded false. It's not dependent on the condition, on the variable I. Okay, there is no loop control variable. We are not controlling the loop with the variable. It's a hard-coded false. So if we run, it's the same as not going into the loop. If we put 1, this is a permanent true. So never stops. Normally we don't use this way, but there are some use of this infinite loop. We'll see today as well how to use infinite loop in a meaningful way. Okay. Also, if we put 10, that means true. Anything other than 0 is actually true. Okay, so 0 means false, and to make more sense, it's better to say true or false. But remember this T capital letter. Okay, if you use small letter T, that is not the keyword true or false. That is not equivalent to 0 or non-zero. Okay, it has to be capital T. So this is an infinite loop. How do we use infinite loop? We can use infinite loop in different ways. Okay, let's say I want to start with the infinite loop. Then inside the loop, I can control when to exit. And that means I can exit the loop not just depending on this condition, but there are other ways I can exit the loop. For example, if I, let's say, greater than 10, okay, colon, and then again indentation for this for this if statement, and we can use another keyword. It's called break. What this break does, break looks for a loop in which this break is located. So this if is not a loop, but this while is a loop. Okay, so when you say break, it will go out of that loop. When this break code executes, it goes out of that loop. Okay, so if you run this, it will start from it will start from 5, print 5, it will increase by 1, and then it will check if it's greater than 10. If it is greater than 10, it will break. If it is not greater than 10, it will go back. Okay, so normally it will go back. But if I becomes greater than 10, it will break, means it will go out of the loop. So I'm expecting when I becomes 11, okay, but I increased after print, so it will print 10, I becomes 11, and this becomes true. Okay, and then it will go out. So last value it will print is 10. First value it will print is 5. 5 to 10. All right. So this is how we can break go out of an infinite loop. Okay, and also there is another keyword, that is continuum. If we use Continuum, typically also we need to use an if statement. Okay, and Continuum can be used in an infinite loop. So let's watch this before going to Continuum. Let's watch this in Visualizer and look at different values. Okay, so we're going to observe the red arrow key, which is the execution point, and also the value of I. Alright, so 5 while true, it's already true, so print 5, it did print 5. I will become 6, it becomes 6. Is I greater than 10? No, right? So it will not break it. The red line will not come to line number 6. Red arrow will not come to line number 6. So it goes back to the while loop. It doesn't need to check condition. It's already true. So print 6. I becomes 7. This will become 7. As you saw. Is the condition true? Is I greater than 10? No. So it will not break. So then 8. Condition not true. Then 9, condition not true, printed 9, became 10, condition is not still true. Now it's gonna print 10, I becomes 11. Now this condition is true. Now it's gonna break. Look at the red arrow. It's gonna come to line number 6, and when it does break, it will go out of the while loop. That means it will come to this print statement. Okay. All right. Now I'm going to use another keyword, that is continue. Okay. So typically, remember that has to be inside the loop. So indented. If you don't indent, then you are already out of the loop. That code is out of the loop. So if I is let's say let's use a modular division. If I mod 2, do you remember this percentage sign? It's a modular division. What it gives you the remainder. Okay, it gives you the remainder. So 4, if I is 4, 4 divided by 2, remainder is 0. If I is 5, 5 divided by 2, remainder is 1. If I is 6, 6 divided by 2, remainder is 0. So this I mod 2 will give you either 0 or 1. Okay, in other words, we can find out even number and odd number. If this remainder is equal to 1, that means it's an odd number, right? If I mod 2 or the remainder of this division is 1, that means I is an odd number, and then we can say print I. So we're going to print only odd numbers. If the remainder is not 1, that means for the numbers 2, 4, 6, 8, those numbers, for those numbers when I is 2, 4, 8, 6, the remainder will not be 1. When you divide those numbers, divide with 2, the remainder will not be 1. So will not print those I. But I will keep increasing. This is an infinite loop, so it will print infinitely odd numbers. Understand? Stop. You see? 9, 1, 3, 5, 7. So it is printing only odd numbers. Let's not put an infinite loop. Let's put while I is less than 100. So up to 100. Okay. So I start from 5, goes up to 100, print only odd number, and this increment of I is not under. If increment of I every time the loop goes back, you increase by 1, so you're checking every number. Just print, it's printed only the odd number starting from 5, 5, 7, 9, 11 and up to 99. Okay, if we make if you want to print only the even numbers, so let's make it smaller, like 20, up to 20. So if I mod 2 is equal to 0 this time, you can say. So if the modular division gives you 0, that means I is an even number, right? So in that case, print I. So it's going to print, it started from 5, this was not true, it didn't print, I became 6, went back to the loop, still I is less than 20, this is true now, 6 mod 2 is 0, remainder is 0, so print I, this becomes 7, go back to the loop, still true, so go into the loop, not true, will not print 7, I becomes 8, still this is true, so go into the loop, this is true, so we'll print 8, becomes 9, this is still true, keep going, when I becomes 20, this is not true anymore, so it doesn't go here in the loop anymore and it gets out. Okay, so this is one way. Another way we could do is use Continuum. Okay, Continuum. So if I mod 2 is 0, then Continuum. What this Continuum will do, will skip the rest of the while loop, but in that case it will not print I at all. So I need to bring this print. Sorry, it will not increase. It will not increase the print. The continue will. If we do continue, the control will go to the while loop from here. It will skip the rest of the while loop. So that means when this is true, it's not going to increase. So we need to put this increment somewhere else. We always want to increase irrespective of what the condition is. Okay, so we will, and we can print right here. So it will skip the print part. If you want to, for the first time, also be careful here for the first time. First time it's never going to take 5, it's going to take 6 because very first time we are increasing. So if you do want to print, this printer statement can go, or depending on where do you want to start, or this can go one more number. Anyway, so let's focus on continue. So this while loop will increase I, okay, but if this is true, it will continue means it will skip the rest of the while loop and it will go back to the while loop. It will not go out of the while loop, but it will go back to the while loop. Okay, so the similar result, if divisible by 2 or remainder is 0, then it will not come to the print loop, it will go back here. But normally, if we don't have this continuous statement, if we don't have this if statement, it will print every number, right? But now we are saying if I mod 2 is 0, continue, that means skip this print part, skip anything after here, that will skip this print part for those I that are divisible by 2. That means, in other words, it will print only the odd numbers. So let's start from 4 because we have an increase here and run. Now let's see this in visualizer. So I is 4, I is going to become, this is true, okay, I is less than 20, I will become 5. Is this divisible by 2? No. So it will not continue, it will not execute the lines under if, which is continue, so it will go to next. That means I is mod, oh, it's already 6, okay, sorry, it's not 5, it was 6. It did print 5. Okay, let's go one more step. So current I is 6, this is true, I become 7, I became 7, this is not divisible by 0, or mod is not equal to 0, mod is 1, 7 divided by 2, remainder is 1, so it will come to print, and will print 7, did print 7. Did I press next 2 times? It already became 8, and then this is true, so it will continue, means it will not come to the print. It did not come to the print, it went back to the while. I is 9, this is not true, so it will come to the print. It will not continue. Okay, I became 10. So as you can see, when this becomes true, it doesn't come to print statement, it goes back to the while loop. Okay, so you can skip the rest of the loops, but you are not exiting the loop. To exit the loop, we use break, right? Okay, now can I use a break here at the same time? Maybe yes. Let's do an infinite loop, and we will, if I is greater than 20, then break. Okay, it's a server issue. Anyway, so we started infinite loop. Okay, I increases. If it's divisible by 2, then it goes back. If it's not divisible by 2, that means an odd number, then it will print, and then also it will check. If it becomes greater than 20, it will break, so it will get out of the loop. Okay. Now, so that it took 21, because when it was it became 21, which causes this one not true, but already printed 21, and then this became true. When it became 20, it did continue. When I became 20, okay, so this was true. It never checked this if condition. When I became 20, okay, so this is true, it did continue, that means it went back to this beginning of the while loop, printed, it didn't come to the rest of the statements in the loop, so it never checked this condition. Okay, but if we put this at the beginning, or before that if, so it will print up to 19. Yeah, it will print up to 19, because when it now it will print 19 will become 20 not greater than 2. It will come to this if, which is not true, so it will go back to the loop. It will become 21, and if this will be true, it will break or get out of the loop. Okay, so we precisely can control what we want to do, which statement is executed before which one, and if we do want to use multiple of them, so you need to be careful what are we writing. Okay, and think step by step, think line by line what is going to happen if you find something is not you're not getting something as you expected. You can always use visualizer, and in other environments such as Anaconda, there is also options for debugging. Debugging shows different variable values, and you can execute step by step. All right, let's look at the slides and let's see what else we have in the slide. So there's an example, n starts with 5. It's a while loop, so you need to have an initial value and a condition check, print that value or goes into the loop if this condition is true. And you also need to change the variable value so that this becomes false at some time. Otherwise, if you don't change the variable value, loop control variable value, this loop will become an infinite loop or will never execute. Okay, if this is false at the first time, then and you don't then it's never execute. But if this is true at the first time and you're not changing the variable value, then it will become an infinite loop. These two statements are under the loop, so one iteration will cause this print statement to execute and also reduce the value of n by 1. There is another way to change the variable value, or sometimes you will see that it's written in a different way. So this line I equals I plus 1 is the same as I plus equal 1. This means I equals I plus 1. So I equals 1 and there's a plus sign before. That means I equals I plus 1. Okay. Also, if we keep the both lines, what will happen? It will increase by 2. We are increasing once by here and once again here. So instead of speculating that, let's use this. It's the same result. If you want to increase I by 2, you can put I equals I plus 2. This is the same as I equals I plus 2. If you want to increase I by 3, you say I plus equals 3. That will execute, that will increase I by 3. It started with 4 and then it became 7, which is an odd number. And according to our logic, it will print only odd number and increase by 3. So 7 plus 3, 10, but 10 is not an odd number. So it's not going to print 10. And then 10 plus 3 is 13. And 13 is an odd number, so it does print. Anyway, so whatever the logic we apply, okay, the computer will do that. I plus 3 is the same as I equal I plus 3. Okay. I plus equals 1 means I equals I plus 1. Alright. Similarly, if you want to decrease, you can say I minus equal 1. I minus equal 1 means I equals I minus 1. Okay, so this line is the same as n minus equal 1. This means n equals n minus 1. Okay. Anyway, so Let's see what else we have on the side. Again, n starts with the number. Is n less than 0? It's not, right? N is not less than 0, so this will never execute. It will only say try off. N equals 0. Is n greater than 0? No. This will never execute. Okay? While true, infinite loop. And here it's taking user input. Remember, input is the function to take user input, and this is the prompt, what is shown to the user. So user typed in hello there, and it's comparing if the user input, which is taken in the line variable, is done, then break, get out of the loop. If not, then print what the user input is. So user typed in this, program printed this. User typed in this, program printed this. User typed in done. So this condition became true. So it breaks or goes out of the loop. That means it comes to the last line and then finish. So this is this program. What this program is doing is taking user input. User type in different values, whether it's number, text. It will keep taking values and will keep showing that value until the user types done. Okay. And here again taking user input. If the user input starts with the hash sign, then continue. That means it doesn't come to the print. It goes back. Okay. So user input showed the input. User typed something with the hash sign, skipped the rest of the code, went back to the loop, did not show the user input, take another input. User typed in this one, program showed that one, user typed in done, and then program exited with break. Not the program, the loop exited with break, and then the last statement is this done. Okay, and we have seen how to use for loop with string values. And with the number values in a square bracket. Also number values. So next, what it's doing is taking a couple of values, okay, and then we'll find the largest value from them. This is going to be our last example today. So let's say for I in, I'm putting some random values, okay. So 3 again, and 1. Let's make a large value here. So 14. Now I want to find out number from the list. We can take user input as well. Okay, we can take user input as well. In that case, you have to make a list and put in that list. And when we learn more about list, I'll show that part. But let's assume that all the values are positive number. So I can say the largest value is A, suppose, okay, or L. L is the largest value, and I will start with a small value at the largest value. And if we assume that all the numbers are positive, then we can say L is -1 or something like that. We start with the largest value as -1. Now I'm going to go through these numbers with a loop. So I is the number in the loop, and I'm going to check if this number I is greater than our current largest value, which is L. Now I'm comparing two variables. If the current I, the value in the list, is greater than the largest value, that so far largest value so far is L. Then change the largest value L equals I. Okay, and keep doing that. You reach until you reach to the end of the list, and then finally when you finish the loop, print the value is L. The largest value is 14. It did find out. You change the largest value something else. Let's say 16. Run again. The largest value is 16. Now, if we actually look at step-by-step execution, then you will see how the value of L is changing. So initially L starts with -1. We are assuming that all the numbers are positive. Okay, that's why we started with -1. But if the number can be negative, then we cannot say L is -1. We cannot start L is -1. We have to use a way smaller number. Anyway, so is I, which is 3, the first value it took, is I greater than L, which is -1? If so, then change L to this new large value. Yes, it is, and it did change. Now I is going to be 14. And now comparing, is I, which is 14, is greater than 13? Yes. If it is so, then change the L value to 14 or I. It did change. So it picked up large value. And then next one, 16, comparing with 16, yes, 16 is greater than 14, so L is going to change to 16. Now, I is 2. Is I greater than 16 or greater than L? No. So L is not going to change. L is going to stay 16. But and for the rest of this comparison, L is going to stay 16. But you cannot stop here because you don't know where the largest value is located. So you have to go until the end. And when the loop finishes, it says the largest value is held in L. So you print L. Now if you want to find the smallest value, you have similar algorithm, similar logic. Okay? For smallest value, you're going to check if I is smaller than L, then you change L. But this code is not exactly correct. You have to be careful. So try to fix this and find the smaller value. Okay, smallest value. This is not the complete solution. Okay, it will not give you the right answer. So you need to fix something, but I showed one comparison you need to change. All right, and that's what the program here did. And we have this example. Another example is making the average. So it's going through the loop, counting how many numbers in the count variable. Count variable starts with 0, and every time it goes through the loop, count increases 1. So it's counting how many numbers. Sum variable starts with 0, and then every time it picks up a number, it adds with the sum. So it add all the number together, put in the sum. It count all the numbers, put in the count, and then finally sum divided by total added result divided by count gives you the average. Okay, so this is giving you how many numbers in there, what is the average, this kind of solution. And here's picking up the value and looking for a specific value. If it's found, then it will show found. If it's not found, will not show found. and this is the finding largest smallest value. I think that's all for today. Okay, so if you have any question, let me know.